Alright, so Chapter 6 review. This is the last review video you're going to have to watch, okay? Chapter 6 is all on systems of equations. So the first way you can solve a system is by graphing. I'm only going to do one of these because this is not my favorite way to solve a system. It's the least efficient way to solve a system. So I'm just going to show you, refresh your memory, and then move on. What I'm going to do is color code these lines so I can see the different lines on there. And the first line I'm going to graph in green. And you're going to graph this just like you would any other line. Put it in slope-intercept form. It already is. Find your y-intercept. And in the green line it's 3. So we're going to go up 3 and put a point. My slope is 2. So I'm going to rise 2, run 1. Rise 2, run 1, and keep going. I'm just going to put 3 dots, 3 points on the line, and then I'm going to draw my line. Alright, and the second one is blue. We are going to, the y-intercept is -2, so we're going to graph that first. The slope is 1/3, so we're going to go up 1, right 3. Up 1, right 3. I'm just going to do 3 points again, and then draw my line. You need to draw both lines long enough that they'll cross. So I extended both of them way farther than the points were, so I could see where they crossed. And the point where they cross is the solution to the system. So that point is going to be -3, -3. And that's your answer. The graph itself is just kind of like showing your work. The point that it gives you is the answer. Okay, for this section we're supposed to solve this using substitution. And I'm not one to, I don't really care how you solve a system. I just want you to be able to do it the way you're comfortable with, because the more comfortable you are doing it, the more right answers you're going to get. But because I have to show you each way, I'm going to show you substitution right here. You know to use substitution whenever it's y equals or x equals. Those are like the magic words. So since you see y equals right here for number 12, which I'm going to call number 2, you're going to substitute what y equals in for y. So we're going to take all of this stuff and we're going to replace that y with it. So I'm going to show my work all the way over here. When I plug that stuff in for this y, I'm going to rewrite this whole bottom equation. I'm just going to replace y with the stuff that it's equal to in the top equation. So it's going to be 2x plus 2. And instead of y, we're going to put 2x minus 1 equals 22. And then you're just going to solve that. You know, if you have two variables, you have to get them together. If a variable's inside parentheses, you have to distribute to get rid of the parentheses. This is stuff I've already told you in a review video. I don't expect you to remember everything I say to the T, but, you know, I'm hoping maybe some of this jogs your memory. So I distributed and I got 4x minus 2. Now I'm going to combine my like terms, so I get 6x minus 2 equals 22. Now I'm going to add 2 to get x by itself, and I get 6x equals 24. Divide both sides by 6, so x equals 4. Now I put a box around it, but that's not the answer. You have two variables, so you have to have two answers, and I only have one. So I'm going to come back over here and I'm going to figure out what y is. Since y is 2x minus 1, and I know that x is 4, I'm going to replace x with 4, and I get y equals 8 minus 1, which is 7. So my solution for this is the point 4, 7. And now let's do number 16, and we'll call it number 3. Since I know what y equals, I'm going to replace the y in the second equation with it. Let me erase all this work. So I'm just going to rewrite this bottom equation over here, and where I see the y, I'm going to replace it with x minus 7. Okay, same deal. I've got this variable in the parentheses, so I need to distribute to get rid of it. And I get 3x minus 3x plus 21 equals 21. And what's 3x minus 3x? It goes away, and I get 21 equals 21. If that is true, which it is, your answer is infinitely many. And what that means is, if I were to have graphed those two lines, they would have been the exact same line. When I graphed them, I would have graphed one line on top of the other line. Just like here, I graphed the green line, and then I graphed the blue line right on top of it. Had I got no solution, that would have been parallel lines. I would have graphed the two lines, and they just wouldn't have crossed. Doesn't matter how long I make them, they're never going to cross. That one is no solution. Okay? Now we're going to solve a system by elimination, and this happens to be my favorite method. I would normally just use elimination right off the bat I could solve everything by elimination. So I'm going to, let's just do this side. We won't do all of them. We'll do 19 first. So 19, what you're looking for is opposites. And I don't have any opposites, so I'm going to have to make them be opposites. So I've got an x and a 5x. For those to be opposites, this needs to be negative 5x. But I can't just change one. I have to multiply the whole equation by negative 5. So that's going to be negative 10. And this is going to be negative 115. Okay, so if I combine these now, these are going to cancel, these are going to cancel, and I get 0 equals negative 60, which is not true, so the answer to that one is no solution. Alright, and then we'll do 23. Alright, I need opposites. I've got 4 and negative 2, so if I multiply the bottom by 2, and I rewrite everybody down here, so I'm going to rewrite the first one, just like I had it. I'm multiplying the whole bottom by 2, so I get negative 4x minus 12y equals negative, I'm multiplying it by positive 2, so that should be plus 12y. And that's not negative, that's positive 18. Now if I combine them, I get 13y equals 39. So y must be 3. Well, if y is 3, let's replace this y up here with 3 and solve for this x. So if I subtract 3, I get 4x equals 18. So x is equal to 18 divided by 4, which is 4.5. So my answer to this one is x 4.5 and y 3. Alright, now we're going to solve a system of inequalities. You graph an inequality the same way that you graph an equation. The only difference is that you have to shade. So I'm going to write shade up here. So we're going to do some shading. So still you do the y-intercept of 4 and the slope of 1. And since that has a line under it, that's a solid line. And then you do the y-intercept of -1 and the slope of 2. And since that one doesn't have the line under the inequality, the equal sign, that one is going to be a dotted line. Okay, and now we have to do some shading. So the solution to this one is right here where the two lines, the two shaded areas crossed. Okay, let's do one more. Let's do this one. So since that one's not in slope-intercept form, we need to put it in slope-intercept form. So I'm going to move this over and make it minus 2x. And then I get that negative y is greater than negative 2x. So I need positive y, so I'm just going to change it. And if I change the sign, I need to change the inequality symbol too. So every sign changes and the inequality symbol flips. So I'm going to graph that one in blue. The y-intercept is 0, so I'm going to put a point there, and I'm going to rise 2, run 1. And then I put a dotted line. Okay, the second one, I need to rewrite it as well, so I'm going to move that over. So it'll be 2y is less than or equal to negative 3x minus 14. And then I have to have just y, so I'm going to divide by 2. And I get y is less than or equal to negative 3/2 x minus 7. So I'm going to go down 7, and I'll do this one in green. Down 7. And then I'm going to fall 3, run 2. Rise 3, left 2. Because I ran out of room, so I had to go exactly backwards. And that one's actually a solid line because it has the equal sign under the inequality. Okay, so now shading. For the top line, I need to shade below it, or not for the top line, for the bottom line I need to shade below. So shade below this line. And then for the dotted line, if you remember, the dotted line's equation was y is less than 2x. So I'm going to shade below the dotted line as well. And the answer to the system is the area where the two shaded parts crossed, which is this area. So the rest of it's actually not necessary. You don't have to have that. You don't have to have it on the graph. I just shade it so you can see where they cross instead of having a test everywhere. I just want you to see where they cross. So that's your answer.